As you recall, the way to get into the census data has become a little bit more convoluted. I'll put a link up for this, but basically to get to what we're doing today, this week, we have to go to census.gov, geographies. I'll just highlight that so I can make a copy of it. Geographies with a S / mapping - files / 2017 / geo / tiger data htm. Okay. Now then, what you're looking at here is, you're wondering, what am I going to do? Well, it's not hard if you just follow these instructions. Go down here to block group. And it says select a state. Now you could do any state you want. It'll do a drop down for you, so you could pick your state. And don't bother with these. And when you do that, what I will show you, because I already did it here, one moment, that mine downloaded, and it went into, I put it in my, with my data, but I noticed that it was the same thing we did several years ago. So it looks something like that, and I'll show it in the folder, and you see there it is. So the ACS _2017 5 year BG block group _09.gdb. It's a geodatabase. So what you would do is then you use your way of extracting, because everybody seems to have their own special way. You can say extract. So this is what we're trying to extract. Or, looks like it's not going to obey. We'll say open with Windows Explorer. And ignore WinZip. So, okay, we'll just do that again. Oh, looks like, okay, it's extracted. And this is the mess that you get with a geodatabase. Now to take our data in there, I'm just going to work with the census data now. We go up to add data. If you think you can use catalog, no, don't use catalog. It'll mess up your life. Go to add data, and this is what we just downloaded. And we put that down there, say add. And then it opens up all the things that were in there. You can see that there are charts for Excel spreadsheets for a lot of things. They're rather big. And here's a shapefile. To get everything in there, we click the first one, and if that's all we want to look at, we'd be fine, but we want to look at everything. So we'll say add. That means you click the first one and then go to the last one, shift click it, and then it'll all come in. Okay, so there's our familiar state of Connecticut. And here is the shapefile. We can take a look at it, show you all the things in the shapefile. And they here's the GeoID data. Now that's the field, I should say. That's all. So what in order to find out what these things all are, you have to find a code name or short name. That's a good way to put it. And it takes some time and look through this. You want to plot out all kinds of things. They have ethnicities and different demographic features. I thought it would be fun to map out educational levels. This is in, okay, how about females with a doctoral degree? That would be, see how many are there, and or where are they distributed? Where's the population density? So there's, it would be B. You have to write this down. If you don't write it down, you'll wish you had written it down. B 1500 2 E 35. And then what we want to do is right-click on our shapefile and go to Joins and Relates, and then do a join. And you want to join the attributes from a table, and the common area is going to be the GeoID. And the table we want to join with would be educational attainment, right? And we validate the join. Okay. And we say okay. Then you can look in the table, open the attribute table, and you can see that all of those features, the B, which I think are the B1500, are the what we're looking for. We're looking for B1500-02. 1500-02 E35. That's our list. That's what we're looking for right there. That's females with a doctoral degree. And if you're over 25. So we'll just keep that in mind. And it's there, and then we can go double click this or right click, and we can go to symbology and go to quantities, and let's make a dot density map, and then we go to B1500-02 35 E35 right here. Put that over there. Our symbol is green. We can change the color of that. How about a hot pink? Hot pink, and that's good. And our dot value, if it's 10, that should be really interesting. We can have our dot size be 2. I think I'll make it 5 or 4. The dot value is 10. And we can say apply and OK. So now we can see where females with doctoral degrees in Connecticut are. Except that, look here, it changed the dot density. It didn't like what we chose, so we'll go back into symbology, the properties, and change the dot value to, how about 4? See, 10 just didn't work. Now it's fairly spread out. So let's zoom to the layer. So we see there aren't a lot of women with doctoral degrees up in Northwest Connecticut or East Connecticut. Probably you're not surprised to find at Yale. This is Yale University is in New Haven here, and they're spread out like that. So that's fairly interesting. Another thing we could have done with this is I would put on the towns. Let's see. I'll put on Connecticut and put on the towns. So that way we would be able to see. I'll overlay the towns here and then make it see-through, and the outer edge should be something other than black. Make it purple. Okay, make it 1. So we should be able to, and we should also label the towns. Look at what it did. It put Connecticut town in there. So what we have to do is go in and find out what the town certainly is in Poly. I'll just put in town, and then it tells you which one of the towns. So see, New Haven is kind of loaded with women with PhDs, and then kind of a sprinkling here and there. We get down to Norwalk. This is where I live. There are a few. It's downtown Stamford. One thing you can there are a lot of high-end apartment buildings, and with people who commute to New York City, do the reverse commute. So there are probably a lot of PhDs in finance.